Here we're going to just start off this lesson just with a little review of our last lesson. What I want you to do is to kind of pause this video just quickly, and I want you to name the two blue vectors. So this one that's 10 meter with a 25-degree angle, I want you to name that. And by name, I mean you're going to write something kind of like what we've got down here. You're going to say this displacement that's shown here is fill in the blank. And then same thing with B over here. This displacement is fill in the blank. And then for the two down here at the bottom, I want you to draw them. So I've kind of named them here. I want you to draw them on this set of axes here. So go ahead, pause the video. I'll wait. Okay, so I'm assuming that you've done them, or at least taken your best guess at them. And let's see how well you did. Anytime you're naming these vectors, let's say for this one up here, let's go this little thing. When we're naming this guy, the magnitude is given right there. So it's going to be 10 meters. The trick, if there's any kind of a trick, is just filling in this blank. What's the direction? And remember, we had kind of talked about this in a previous video, I think. If the angle touches, so again, it's going to always touch the vector itself, the hypotenuse, but whatever side it touches right here, that's what's going to come first. Okay, so it touches west. So west is going to come first, then the angle, 25 degrees. And then this vector right here, the arrow, is between west and north. Okay, so the other direction here has to be north. You could imagine if you started right here, you could walk west, and then you could walk north, and you could end up at the same spot. Okay, so that's the name of that vector. It's not a very fancy name, not like some clever name or something, but it's just the magnitude plus the direction. For B then, we've got a magnitude of 15 meters. And again, we just need to fill in this direction. So if you didn't already, pause the video now that you've seen A, see if you can get B. This 10 degrees touches south. So we're going to have south, then 10 degrees. And then the other direction that it's kind of between is west. So south 10 degrees west. So there's that one. There's that one. So those are the names of those two vectors. For the second one here, I've given you the names and I want you to draw them. So we got to figure out where they are first. So again, that first direction that's right here is east. Okay, so it's going to be between east and it's going to be between south. Or it's going to be between east and south. The 15 degrees, though, we're going to draw our line in here, and the 15 degrees should touch the first one. So it should touch east. So there's 15 degrees. This vector is 25 meters long, and that's it. Same idea here. If you couldn't do B already, pause it right now. See if you can come up with B before I do. This thing here, again, we've got north first, so it's going to be between north and east. The vector angle has got to touch north because it comes first. So right there is our 20 degrees. Here's our vector. Don't forget the arrows. Always draw the arrow to show which direction it's going. And this length of this line here is 22 meters. Okay, so there's a little review of our last lesson. Let's go ahead and get into velocity and uniform motion. A couple quick things here. We talked about vectors and scalars. So just as a reminder, these guys here that have the arrows on top, the harpoon, it sometimes is called. This guy here is a vector. For average speed, we'll get to that one in a sec, but that one's going to be our scalar. So this one down here is our scalar. And we'll get to that one in a sec. I gave you the symbol here. We often see this thing as just V with that's a V, by the way, kind of a written V. V with the harpoon or the arrow above it. Sometimes you'll see it as average velocity. Sometimes you'll see it without the average, just like that. The equation is given as right here. Velocity or average velocity is displacement divided by time. For speed, it's going to look pretty similar. Let's switch over to a nice purple. It is just V. Again, sometimes written more like a written V. You know, sometimes people will do, I don't know, something like that. That's not a very nice one, so I'm going to get rid of it, but we're going to see something like that. Or again, you might see v with an average, but if it does not have the vector sign above it, then what we're talking about is speed. The equation, it's going to look a whole lot like the one up above, but just notice the lack of vector signs, okay? No arrows on this thing. Okay, so there's the equation for average speed. They might look the same, but just remember, for that symbol, this is from our last lesson, that symbol right there is displacement. And this symbol right here is distance. Often written without that delta sign, but for sure with no arrow on top. Okay, so sometimes you'll see no delta sign in here. If that thing's there, not there, that's fine. So I got a quick example here for you. Dumbo, this is the elephant Dumbo. I think I came up with this after seeing that cheesy movie. The elephant flies 3 meters east, then 4 meters north in 5 seconds. Find the average speed. What we just said above was average speed is distance over time, or change in distance over time. Which means, first of all, we got to find the distance. If we go 3 meters and then 4 meters, remember distance, we don't care about the direction. Excuse me, you could just say in here d total is d1 plus d2. So d total is 3 plus 4. D total 7 meters. That's something you could easily do in your head. If we were going to fill in then this equation up here, we could say that it is 7 divided by 5. So 7 meters divided by 5 seconds. That average speed, I'm kind of running out of room here. Average speed then is, what does that work out to? 1.4 meters per second. Just as a reminder, the 7 was in meters, the 5 is in seconds. The units I end up with here then are meters per second. Okay, so that's the easy one. The little bit harder one then is velocity. And the only reason velocity is any harder is because we first need to find displacement. Okay, so I'm going to go ahead and write the equation. I'm going to write it up high here. Average velocity is displacement. Remember that with the arrow on top, that's displacement over time. Okay, so I'm going to come off to the side here. I'm just going to draw this thing. We're going, or the elephant's going 3 meters this way, 4 meters this way. So here's 3, whoops, here's 4. The resultant displacement is this side right here. So again, sometimes people put an R for resultant, but the displacement is the hypotenuse side of the triangle. And it's always good form to just kind of remind people, whoever's looking at your work, you know, if you can kind of see this sort of thing in here. And we could choose positive directions. We could say north is positive and east is positive. It doesn't really matter in this one, but we'll see that more in other ones. It matters. To find out the displacement, then we're going to use Pythagoras. Okay, so I'm going to say this thing squared. I'm going to leave off the triangle and the arrow just to make this look a little bit simpler. Is 3 squared plus 4 squared. That is 25. If I square root both sides, I'm going to get dr is 5 meters. Now I can sub this thing in. So this thing's going to go up in there. Okay, so this thing is a displacement. Well, actually, let's go ahead. While we're talking about displacement, really to make this thing into a displacement, I do need to find this direction as well. So again, little review of last lesson. The angle we want is the starting angle. To find that angle, then, we can say tan theta is opposite over adjacent. Let's see, that theta, whoops, always switches color on me, 53 degrees. And then, just like we did up at the top, the angle touches east. Okay, so this line right here, it touches east. So east, 53 degrees, and then north is kind of our second direction over there. It's this displacement that we are filling in up here. Okay, so average velocity is the displacement, which is 5 meters, divided by the time, which is 5 seconds. We can do this one in our heads. This is 1.0 meters per second. But remember, I want this thing to be a vector. And I'm kind of out of room here, so I'm just going to come down below here and write this direction. Same direction as the displacement, okay? This east, 53 degrees north. there is my average velocity. Okay, so average speed and average velocity are not the same thing. It's not like I just add a direction, you know, over here. I can't just add a direction onto speed to get velocity. They actually use different quantities. So velocity is using, here, let's go to this. Velocity is using displacement up here. And speed is using distance up here. A couple quick other things that we can mention here. Instantaneous velocity is velocity at a certain point in time. I don't know why I didn't underline. It's kind of backwards. Usually the word is underlined, not the definition. But anyways, instantaneous velocity. Velocity at a certain point in time, like a certain instant. If you get pulled over by the police for speeding, they don't care about your average velocity, including when you were stopped at the red light and, you know, driving slowly through the McDonald's drive-thru or something. All they care about is how fast are you going right now at this instant when they put their radar gun on you. Okay, so that's the instantaneous velocity. You'll sometimes see it written as, whoops, dang, that's no good. You'll sometimes see it written as V instantaneous as opposed to V average, which we saw above here somewhere. Yeah, up here. Okay, so that's instantaneous velocity. That's not one, well, we will see that one for sure, but not for a little bit. Uniform motion, though, we'll see a lot. Uniform motion means constant velocity. Okay, and remember, velocity has both magnitude and direction. If the velocity is going to be constant, that means that the speed of it has to be constant, the magnitude, and also the direction has to be constant. Okay, so watch for this. There's a good trick question in there. You'll see it on a quiz or a test, and don't be distracted by this thing or don't be fooled. It does mean both. Both speed and direction are constant. Try these textbook questions, you guys. They're good ones.